In the previous lesson, we talked about the first half of chapter 5, which was learning about slope and how to write an equation of the line. In this part of chapter 5, we are going to learn alternate forms of the equation of a line, deal with parallel and perpendicular lines, and talk about the graph of absolute value. So an alternate form, remember the other day we did point or slope intercept. All right, we're going to use that most of the time. All right, but I'm going to show you why knowing these two forms could be helpful. All right, sometimes it's easier to use this form when given the slope and a point. All right, so here is the form. It's 1 minus y1, or y minus y1 equals m times the quantity x minus x1, where x1 and y1 are that given point. So below I have an example. Given the slope of 2, write an equation of a line in point slope form through the point 4, 5. So you're given a point, you're given a slope, and you're going to write the equation like such. Okay, and just to show you, you can convert this equation so that it looks like slope-intercept form if you're more comfortable with that. And by that, all you're doing is isolating the variable, so you're solving for y like you would in a regular equation. I'm going to distribute this 2. So I have 2x minus 8. From here, I'll just add this 5 to both sides. And I get y equals 2x minus 3. Now we are in a slope-intercept form. Right now we're in the form that we like best, at least in my opinion, and that's what we're going to refer to most often. All right, notice the slope didn't change. Over here it's 2, here it's 2. The slope will not change when you're converting it. The next form is standard form. This is another type of equation. Standard form is the form ax plus by equals c. This is helpful when you're trying to find both the x and y intercepts. And if you're given an equation like this, that helps because if you're given a graph, and we'll find the x and y intercepts below in a second on this graph. So I'll just mark this graph out and we'll do an example. So in order to find the intercept, all you have to do is plug 0 in for the opposite variable. So if your question asks find the intercepts of the line x minus 2y equals negative 2, well, in order to find the x-intercept, you're going to plug 0 in for y. Okay, so it's the opposite. So if I plug 0 in for y, as you can see, my equation becomes x minus 0 equals negative 2. So x equals negative 2. And since it's an intercept, that means where it intercepts, the value will be 0 for the opposite variable. So if x equals negative 2, and I forgot to put the negative in there, x equals negative 2, then y is 0 if it's an intercept. So our point is going to be right here. For the y-intercept, we plug 0 in for x. So now our equation becomes 0 minus 2y equals negative 2. So we have negative 2y equals negative 2 when we simplify that. If we divide both sides by negative 2, we get y equals 1. And again, since it's an intercept, we know it's a y-intercept. That means the x value is 0. And our y value is 1. So we're going to plot the point 1, 0. Now we have 2 points on our graph. We can draw a line. So that's how we would use the standard form most often. Parallel lines. All right, parallel and perpendicular lines are probably the two most important things of this lesson. It's important to know that parallel lines are lines in the same plane that don't intersect. They never, ever, ever intersect. Here is the important part. Parallel lines have the same slope. The same slope. So if a line passes through the point 12,5 and is parallel to the graph of y equals 2/3 x minus 1, what is the slope of that line? Well, if the slope of the line parallel to it is 2/3, right, because the slope is m, which is always in front of the x, then the slope of the parallel line and these two lines here are a symbol for parallel. So slope of the parallel line equals 2/3. They're the same. The slopes are the same. So if you have the slope of the parallel line and you have the point 12,5, in order to find the equation of that line, remember we just plug that in. So we have our equation y equals mx plus b. So our y will be 5. Our m is 2/3 because it's parallel and it's the same. Our x is 12, and then we have plus b. Whoop. I totally jacked that up. There you go. I put the parentheses in the wrong spot. So from there we get 5 equals, if I do 2/3 times 12, all right, you'll see I get 8 plus b. So b equals -3 after I subtract 8 from both sides. So once I have b equals -3, I know the slope. My equation then becomes y equals 2/3 x plus -3. I got my slope and I have my y-intercept. We would follow the same format for perpendicular lines, except perpendicular lines have opposite reciprocal slopes. And what opposite reciprocal means is you take the opposite and flip it. So I'm just going to use a little abbreviation up here. So if I have the number -2, the opposite of that is 2. The reciprocal of that is 1/2. So the opposite reciprocal means flip the fraction. Remember, this can be written as a fraction by putting it over 1. -2 over 1 is the same thing as -2. So the opposite of -2 is just 2. If we flip it, it becomes 1/2. All right, say we have -5/3. The opposite reciprocal would just be 3/5. If we had 2/5, the opposite reciprocal would be -5/2. Hopefully that makes sense. So here, if we're looking for a line perpendicular to the one we found before, the slope of our new line is going to be -3/2. So now we have to plug that into our equation. Y equals mx plus b. So 5 equals negative 3/2 times 12 plus b, which gives us 5 equals negative 18 plus b. We add 18 to both sides. We get b equals 23. So our equation is y equals negative 3/2 x plus 23. All right, so parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. This is going to be a quick review on scatter plots. A scatter plot is just a graph that relates two different sets of data. So you're just plotting points of an ordered pair. If the data is showing that it's going up in both directions, it's a positive correlation. Okay, if it shows that it's going down, it's a negative correlation. And if it's all over the place, then it's no correlation. That's what you need to know about scatter plots, and you also need to know about trend lines. So a trend line is a line that fits the best between your scatter plots. So in order to find the equation of that line, you'd first draw a line that fits your scatter plot, pick 2 points on that line. So with this line, I may pick this point here and this point here. Now that I have 2 points, I can create an equation of a line by finding the slope first and then plugging one of those points into that y equals mx plus b to get an equation that says y equals some slope x plus whatever the y-intercept is, which on this graph it looks like it should be 0. Last and final thing we're going to review is just the graph of the absolute value. All right, the graph of the absolute value, this graph here, and it's written in this box, is just y equals the absolute value of x is shaped like a V. All right, and then translations, if we move it, so if it's outside of the absolute value sign, then we're going to do what it says. So here, absolute value minus 2, that means we're going to shift it down 2. All right, the equation of this graph, as you could probably guess, we would add 2 because we're shifting the graph up 2. When it's inside the absolute value sign, we're going to do the opposite of what it says. And we're shifting it left and right. So if we have y equals x plus 2 inside the absolute value sign, we are shifting it to the left. Even though it's plus 2, since it's inside this absolute value, we're doing the opposite. So we're going left 2. Then this one here would be y equals x minus 2. So we're shifting it right 2. This is just something you're going to have to memorize, and we'll see a little more of this. I don't know how much this will show up, but just try and remember these shifts. Best of luck to you guys. We have a test coming up next week. I will make sure that I get you guys some answer sheets as long as you have submitted the review questions from all of the CYUs.